Okay, folks, we are at the very last lesson of this very long unit. Numbers, radicals, and finally exponents. This is the highest level stuff, part 2 of variable bases. Are you ready for a challenge? I know I am. These next questions will put your skills to the test. If you plan on taking 20-1, if you want to be challenged in mathematics, these are the questions for you. Okay, these are all fair questions for Math 10C, but these will be the hardest of the type here. Okay, so let's go over them one by one. Remember that tip from before? Have a plan, be methodical. Numbers with numbers, variables with variables, work inside out. Try to follow BEDMAS rules. Do one step at a time. Try not to do a lot of things at one time. Simplify each of the following expressions and write the answer with positive exponents only. Okay, first one. Can't simplify inside the brackets anymore, so I'm going to take this exponent 3 and apply it to everything. So that's x squared to the third is x to the sixth, y to the third, z to the third, times x y squared over x z squared. The numerator, let's combine that using product law. That's x to the 6 plus 1, that's x to the 7th. Y to the 3 plus 2, that's y to the 5th. And z to the 3rd, all divided by x z squared. Let's use the quotient law. X to the 7 minus 1 is x to the 6th. Y to the 5th stays y to the 5th. And z to the 3 minus 2 is z to the 1. So my final answer is x to the 6th, y to the 5th, and z. Next one, rational exponents inside brackets with an exponent again. Let's simplify what's inside the brackets. Because I have an A and an A, B and a B, I can use quotient law to make it into one expression without having a fraction. That'll make it easy. So don't apply this exponent yet. So I'm going to go A to the 1/2 minus 3/2, quotient law, B to the 4 minus 5, and this is all squared. That's A to the negative 2/2, B to the negative 1, all squared. That's A to the negative 1, A to the negative 1, B to the negative 1, squared. You could do this, so I'm going to go 1 over AB, so 1 over A to the 1, B to the 1, all squared. And then let's apply that exponent 2 across now. Everything's simplified inside the numerator, correct? Or sorry, inside the brackets. So that's 1 squared over AB squared. That's 1 over A squared B squared. Done. 25, A to the 4th C, all to the 1/2, divided by AB cubed. Okay, so can I simplify anything inside the brackets first? No. In the numerator, can I simplify the exponents? Absolutely. So let's see. Numerator, that's 25 to the 1/2, C to the 4 times 1/2, C to the 1/2. Oops. Oh, man. Sorry. A to the 4 times 1/2, C to the 1/2, divided by AB cubed. Let me leave that alone for now. 25 to the 1/2, that's like saying square root of 25. A to the 4 times 1/2 is A squared. C to the 1/2, AB cubed. That's 5A squared, C to the 1/2. Let's evaluate AB cubed. That's A cubed, B cubed. Okay, let's do some quotient law. That's 5A to the 2 minus 3, that's negative 1, C to the 1/2 divided by B cubed. Well, we don't want to leave negative exponents, so I'm going to take the reciprocal of A to the negative 1, which means I flip it to the bottom. That's 5C to the 1/2 divided by AB cubed. Okay, last one here. Can I simplify, letter D, can I simplify anything on the inside first before I apply that -3 exponent? Absolutely. One thing at a time. So inside the brackets, I got a whole lot of quotients to do. Okay, so this is going to actually turn it into a single term, or sorry, no more fractions. So 36 divided by 12, that's 3. And then let's do quotient law on the x's. X to the -2 minus 1. Y to the 1 minus 2. Z to the 5 minus 1. All to the -3. Leave that -3 exponent alone. 3 x to the -2 minus 1 is -3. Y to the 1 minus 2 is -1. And z to the 4th, all to the -3. Okay, before I apply the exponent of -3, what can I do? Let's, inside the brackets, make those negative exponents positive. Could you apply the -3 exponent across? You sure can, but I don't recommend it because then you'd have to evaluate 3 to the -3. So let's do this. Draw a line. 3, x to the -3, y to the -1. We're going to flip that to the bottom. Negative exponent rule, or take the reciprocal. What's left at the top? Z to the 4th, and it's still exponent -3. Okay, now let's take care of this negative exponent 3, -3, by using the negative exponent rule for fractions. I can flip what's on the inside, x cubed y over 3z to the 4th, and then I can make this exponent positive. That's the rule. Now all the exponents are positive, everything's simplified within the brackets. Now let's apply this exponent 3 across every single term inside the brackets. Okay, so that's x cubed y cubed divided by 3 cubed z to the 4th cubed. That's x to the 9th y to the 3rd divided by 27 z to the 12th. Done. Yeah, there we go. Here's another way you can do this. What if you decided that you wanted to? Hopefully you can see from the beginning, I don't want to distribute that -3 exponent across. Man, that's a lot of work. That's hard. The other way you can do this, alternate, is this. From the beginning, you can flip the fraction. That's 12x y squared z over 36 x to the -2 y z to the 5th, and that's all to the 3rd. Notice this exponent -2. When I flipped it, I don't change that -2. I only change that one, the -3, to a +3. Now evaluate as we did before. 12, let's make 2, actually, let's go 12 and 36. That's going to be 1/3, right? And then let's combine using quotient law. X to the 1 minus -2. Yep. Y to the 2 minus 1. And Z to the 1 minus 5. Okay. And that's all to exponent 3 on the outside still. 1/3. That's x to the 1 minus -2 is x to the 3rd. y to the 2 minus 1 is y to the 1, and z to the negative 4, all cubed. Now before I apply, well, I guess I can apply the exponent across. I could change the z to the negative 4. Let's do that. That's in the numerator. That's 1x cubed y. And then the 3 is in the denominator, z to the 4th. And that's all cubed. Now let's apply the exponent across everything. That's x to the 3 times 3 is x to the 9th. Y cubed divided by 3 to the 3rd is 27. And then z to the 4th is z to the 4th times 3. That's z to the 12th. And that's our final answer. Is it the same? Look at that. It is. Okay, so there isn't one correct way to approach these problems. What would I do? I would prefer this way. One step at a time, simplify everything inside the brackets, and then evaluate to the very end. Logical conclusion, positive exponents. Okay, folks, we are done. This was a challenging unit. Go for the exercises, do the review. This is probably one of the most challenging units in this entire course. All right, good luck.